Okay, so the answer to that question I think is displayed fairly well in this kind of cartoony slide. What it's showing is the principle behind the centrifugal force. So people probably are familiar with the centrifugal force, even if you don't know it by name. The centrifugal force is the force that keeps water in a bucket if you swing the bucket around upside down, or the force that keeps a yo-yo at the end of the string if you spin it and do the around the world trick. Um, Centrifugal force in the Earth system is caused by the Earth and Moon combination of rotation. Just because the Moon is much smaller than the Earth doesn't mean that the Earth is exactly stable with respect to the Moon and the Moon is perfectly rotating around it. As you can see in the diagram in the top right corner, the center of mass between the Moon-Earth system is actually not located at the pole. So we have this system where the Moon and Earth are rotating around a point in space and literally rotating around each other. Since the Earth is not completely stable, that centrifugal force is present and it affects all things on Earth. In the tide's case, it is the opposing force of gravity when you have the Moon and Sun both on the same side of the Earth in a new moon position. When that happens, the Earth is trying to sling the water. The centrifugal force is trying to sling water off the other side of the Earth, while the gravity from the Moon and Sun are trying to pull the water towards themselves. You can see down in the bottom left corner how we have this comparison of forces, and as it turns out, they're about equal. So we end up having this high tide bulge on the Sun-Moon side as well as the high tide bulge on the opposite side, on the dark side of the Earth.